Uh, Everything is updated. Let me just check if it's actually gone live. Okay, Twitch is working. YouTube. Sorry for the delay today. I was trying to solve some issues with OBS. After I was running the Vulkan program, and then I exited, it would sometimes get stuck on the camera scene. So that seems to have still be happening. I don't know. Was supposed to be fixed. Anyways, let's continue where we left off yesterday. Yesterday, we finally got the shaders to compile automatically and be able to add them directly from here. So now we can continue. I think the next is fragment interpolation. So I'm guessing some like smoothen, color smoothen type of thing. Let's start.
In storage qualifier, it is also possible to pass values from the vertex shader to the fragment shader. We do this by declaring and initializing a variable in the vertex shader with the out storage qualifier. Then for each out variable in the vertex shader, we should have a corresponding in variable declared in the associated fragment shader. Note that what's important here is that the locations match. The variable's name can actually differ between the vertex and fragment files. But hey, wait up. Our vertex shader runs per vertex, but the fragment shader occurs after rasterization in our pipeline and runs per fragment. How do we go from a per vertex value to a per fragment value? Each of our vertices can set the out variable to a different value, so ideally what comes to mind is that we need to combine these values in some way. The answer is linear interpolation. Interpolation, simply put, is the process of estimating an unknown value that falls between known values. It's pretty much like connecting the dots. There exists many different possible ways to do it. Linear interpolation just means that we do this by using straight lines. This is perhaps the most common mathematical operation in computer graphics. If we let a variable t correspond to the fractional distance between 2 points, then for any value of t from 0 to 1, we get a point that falls along the line connecting the two endpoints. The position of a point can easily be calculated by the sum of the endpoints, weighted by t and 1 minus t. For example, a value 1/3 of the way between a equals 6 and b equals 12 gives us the value of 8. Additionally, this easily extends to multiple dimensions. Each component is just simply calculated separately, so our new x is just the linearly weighted
This
sum
is
of
a
our point x components, and the y component is just the weighted sum of the 2 points on the x component and
skip
on the y
ahead.
component. Therefore, calculating px and py is quite straightforward. You can interpolate any type of value you want, not just positions. Listing each color, so the red component will blue lines, but most often we will be working with barycentric coordinates. Fortunately, the graphics pipeline handles calculation of the barycentric coordinates for us automatically. So in this video series, I won't go through the full derivation since it is unnecessary for our purposes, and we'll just go over the basic ideas. If we have 3 points A, B, and C, we can think of barycentric coordinates as a scaled, non-orthogonal coordinate system with basis vectors B minus A and C minus A. Okay, let's slow down. If you're not familiar with linear algebra, don't panic. This is still pretty simple conceptually. Essentially, it is kind of like performing a linear interpolation between A and B, with the fractional distance being denoted by the beta symbol, and then doing a second interpolation between A and C, and denoting that weight with gamma. Then to calculate an interpolated value at point P anywhere within the triangle, we can use beta, gamma, and 1 minus beta minus gamma as the linear weights for the 3 points B, C, and A respectively.
This is like vector calculations essentially.
This is just like basic linear interpolation, but instead of one t value parameter, we have 2 parameters, beta and gamma. This also works just as well in 3 dimensions.
Okay, just
Often, we'll simplify 1 minus beta minus gamma to just alpha. Then we get the equation P equals A times alpha plus B times beta plus C times gamma, with the additional constraint that alpha plus beta plus gamma equals 1. So hopefully I've explained well enough that conceptually you understand how this works. One nice feature of barycentric coordinates is that a point is inside a triangle if and only if alpha, beta, and gamma are all greater than 0 and less than 1. Okay, now back to Vulkan. In our graphics pipeline, I've previously said the purpose of the rasterization stage is to break up our geometry into fragments for each pixel the triangle overlaps. In addition to this, for each fragment, the rasterization stage will automatically interpolate any variables we've declared as outputs from the vertex to fragment shader using barycentric coordinates. Each fragment has different coordinates based on its position within the triangle, so the input color to the fragment shader will be slightly different each time the fragment shader is run. So now let's add a second attribute. In your vertex shader, add a new layout location equals 1
and in the shaders again. And this is in the vertex shader. Okay.
In Vec3 color. Now what we want to do is
Layout location equals 1 and vec3 color.
pass this color from our vertex shader to the fragment shader. We can do so by specifying an output attribute.
And let's say layout location equals 0 out vec3 color. Okay.
Position is at input location 0. That has no effect at all on us setting the output location of frag color also to 0. Then in the main function, just pass through the input color to the frag color, with frag color equals color. Next, in the fragment shader, we need to add the corresponding input to this output. So layout
Suppose frag color equals color. Save, and now it's adding in a variable layout location equal 0 and vec3 in color. I'm assuming that's what you name it.
color. All that matters is that the
Frag color.
data types match. The variable's name can differ between the shader files. Then just replace the hard-coded RGB values with our frag color variable. So constructing a vec like this is values from our vec3 frag color and 1 as the fourth component. Now back in the model class, let's update the vertex struct to have a color attribute. Now there's two ways we can structure this. We
in the model
create a second separate binding for the color attribute, or we could interleave the color attribute with the position in the existing binding. The implementation is simpler for interleaving, so we will go with that option. All we need to do is add the line glm vec3 color to the vertex struct. Now in the implementation,
let's say glm vec3 color.
operator on vertex, the stride will already be adjusted to account for the additional color attribute. But we do have an additional attribute now, so we will need to update the getAttributeDescriptions function. First, update the attribute descriptions vector to
This is in the CPP. See here, give a description to
copy and paste these 4 lines and make sure to update the indices. Otherwise, you won't get a compiler error, but
let's change audience to 1. Save. Okay.
weird behavior at runtime. So the binding is still 0 because we are interleaving both position and color together in the one binding. Next, the color location is 1 because this needs to match the location used in the vertex shader. Don't forget that it's the location that matters, not the variable name. We could call the color attribute one thing in our vertex struct and something completely different in our vertex shader, and it wouldn't be a problem, so long as the locations match. Then the format needs an additional component because color is a vec3 rather than a vec2. So add b
Auto G32 B32 Yeah.
And now our offset can easily be calculated using the offset of operator, which takes a type as the first argument and a member name as the second. So we have
Offset of vertex. Set of type and number. Yeah.
and then color. So this
Don't see, don't be.
position member variable, but it also makes it so the order we've declared the members in our vertex struct.
Location 1. I almost missed that.
Alternatively, you may prefer this construction. Just remember the proper order of arguments is location, then binding, format, and offset. And we don't actually require any other changes in the model class.
We'll keep it for now. We'll change it in the future, maybe.
And we don't actually require any other changes in the model class. When we create our vertex buffer, the new size is already accounted for, and when we copy our data over, the interleaved color data will be copied automatically as well. If any of this is confusing, I'd recommend re-watching the first 5 minutes of tutorial 6. This is where I explain binding and attribute descriptions in much more detail. So all that's left to do is to provide RGB values for each of the vertices. Note that we don't get any errors right now, and if you build and run, you get a black triangle, because the default initialization here will set our GLM vec3 color to 0, 0, 0. In the first app implementation file, load models function, navigate to the vertices initialization and set the first vertex to red. So in between the two braces here, add 1, 0.
Let's hit play first and see if we get the black triangle. Okay, nice. It's compiling the shadows. That's on a black screen, so yeah, at least it's doing something, hopefully. Position. Let's run it again. Let's see. Okay, it's slightly more visible, but it's like clearly there as compared to before. Okay, well, let's see. First app CPP. First app load model. Yeah. First app load models. I'm guessing it won't work with this. Let's try it and see. Let me just go to the function. Yes, I can see vertices pushback. Say left of it. For now, let's just keep it simple and go back to the like normal triangle. Vertices. Or 0.5. Let's see. Zero point zeros minus 0.5, 0.5, 0.5, and yeah, and 5 minus. Also enter.
Then
Let's do this jacket. Yeah, it has to have one more bracket here. Close a bracket here, comma 1, comma 0, 0.0, comma 0.0. F, F, F. Yeah. Let me just copy paste this 3 times. Comma, comma. Okay, positions. What is this? Aggregate initialization of type. Let's change this to 0, 1, plus 1, and 0. And what are the values? 0 0.5, 0 0.5. And 5 minus plus. Yeah.
to green, so 0, 1, 0, and finally set the last vertex to blue, so 0, 0, 1. Let's build and run, and we get a multicolored triangle. So the graphics pipeline automatically handles.
Okay, let's see. Loading. Okay, nice. It's matching the result. And close. Let's see, vertices, GLM. Whatever, let's give it. Aggregate initialization types. Let me just check out what that is here. C line aggregate initialization of types. Index can be use the visibilities, change and layer. Saline over let's mm. What do you do with this thing? Let's see. So the total control of show as default turn off add. No, I'll deal with that later, I guess.
Barycentric coordinates of each fragment, and the vertex shader will be run once for each corner of the triangle, so only 3 times in this case, because we only have one triangle. The fragment shader is run once for every pixel within the triangle, which if your window is still 800 by 600, our triangle covers 1/8 of the window, so that would be 60,000 pixels. Each time the fragment shader is run, the frag color input will have a different value based on the location of the pixel relative to the containing triangle. These interpolation calculations are done blindingly fast using dedicated hardware on your graphics device in parallel. GPUs use what is called an SIMD model, single instruction, multiple data. What this means is that it is able to execute the same instruction on multiple different input values, but all at the same time rather than sequentially. So for example, imagine it takes a group of fragments. The size of this group is dependent on your specific hardware. Each fragment has a different input of barycentric coordinates. The device can
Just some parallelization
first
stuff.
calculate A times alpha, but for the entire group simultaneously. Then in lockstep, it proceeds to the next instruction, B times beta, for the entire group. Then C times gamma, and so on until the entire interpolation calculation has been completed for all of the fragments within the group. This is one of the main reasons why GPUs can process large amounts of data much quicker than a CPU. It's a trade-off. GPUs sacrifice flexibility for volume. Of course, this is a drastic simplification of GPU architecture, and I only have a novice understanding on this specific topic myself. I think this is a good enough view for getting started with. You will see in the choose swap surface function, I am using unorm as our
Fixing swap
computer graphics.
surface.
If you navigate to your swap chain class implementation, you will see in the choose swap surface function,
swap chain. Swap surface format. Yeah.
but with a non-linear color space. Change unorm to sRGB so that gamma correction is applied. Explaining this mistake could be its whole own and have linked it in the description. It's an optional read.
Yeah, much nicer. And the background is now like clear. Sort of just not fully black, but like pretty black.
It's really relevant until we're farther along in the series. And that's it for today. This was mostly a theory-based video, and we didn't get to do too much coding. The next couple videos should be more coding focused, though. Let me know how you feel about the balance of things so far. Do you want future tutorials to be more coding focused, or should I continue with the current balance between theory and code? Please like and subscribe.
Yeah, this was a good tutorial. Very quick. Let's go to the next one.
Unfortunately, resizing the window isn't quite as simple as setting the GLFW window hint resizable to true. If you've already tried doing so, you will find out that when you try to make the window smaller or larger,
and now we are resizing the windows. Okay, for now, let's save the current changes. And Vulkan to Honolulu to ship. Mhm. Connect push. Okay. It's loading. Yeah.
The program will crash.
Mhm. Mhm.
Because the LVE swap chain class encapsulates a Vulkan swap chain, frame buffers, and color and depth attachments. All of these objects have a fixed size once created equal to the size of the window. Therefore, whenever we
I'll be back quickly. Let's go back. Yes. Yeah, impact.
Size has changed. We will need to recreate a new
Just needed to do something that would wake me up a bit. I remember I used to play some games of chess to wake me up before. I shall do that. Mm, chess.com. Again, I'll just quickly hide this and come back. Uh, I'm back once again. I've now logged into chess.com, so if I need to take a break, I can just play some games in the meantime. Or I can do some monkey type stuff. But that's for later now.
new swap chain using the updated dimensions. Additionally, if we construct a new swap chain, we might also have to build a new pipeline as the graphics pipeline currently relies on both the Vulkan swap chain, frame buffers, and color and depth attachments. All of these objects have a fixed size once created equal to the size of the window. Therefore, whenever we observe that the window's size has changed, we will need to recreate a new swap chain using the updated dimensions. Additionally, if we construct a new swap
What is
chain,
the
we might
swap
also have
chain?
to build a new pipeline as the graphics pipeline
Swap chain overview. Does it explain it well? Not sure.
The swap chain is a series of frame buffers used to display images to our window. In previous
Oh, it's just the series of frame buffers. Okay.
pipeline currently relies on both the swap chain's width, height, and render path.
The
This is a
name is
dependency we
not
can avoid most of the time by using a
very obvious. Maybe like frame buffer array or something. Yes, that would make no sense, but I'm sure someone out there had a reason to name it this.
dynamic viewport and
Anyways,
scissor. Finally, the command buffers are pretty dependent on the swap chain. We are still using a one-to-one relationship between command buffers and swap chain images, and when we record a command buffer, we use the swap chain's extent, render pass, and frame buffer. But it is pretty common to re-record the primary command buffers every frame, so this seems like a good a time as any to implement that as well. First, a thank you to the viewer who pointed this out. In the pipeline class, when deleting the copy operator, this shouldn't be
pipeline
void operator
class.
equals, but LVE pipeline reference operator equals.
Yeah, check it out. LV pipeline HTTP. Yeah, LV pipeline. Honestly.
Done this in the swap chain and device code as well, so make sure to update all occurrences of this mistake in the swap chain and device code as well.
Device and swap chain. LV swap chain. And device. Yeah. LV device. Answer. Seems like there's an update. Just I don't have a thing for the release notes. Let's check it out though. CLIN 2025.3.1. Update and restart. Update and restart. I'm guessing it's just minor bug fixes, but still. Faster refactoring with CLIN over language engine. 78% has increased with CLIN. Up to 4x faster code highlighting and error. CLIN Classic, CLIN Movie. Okay. Deepen set into compile time evaluation. Expanded debugger. The islands theme. I wish the Kadu theme gets updated with the island look as well. I think it'll look nice. Let's do this. Settings, themes, get more themes. Did it finish installing? Let's see what it could do. Cell dark theme. Simple dark theme, inspired plain theme, Kadu theme. Source code, no, I prefer the JetBrains mono. Yeah. Over the rest of the plugins. Everything else done downloading. Oh, there's a thing. Research. Well, that's happening. Let's play a game of chess in some thoughts. Yes. Yeah. Next start. Already beat that guy. Okay, yeah. This is still updating. Probably should have done that after the stream, but whatever. Mm. Really messing this. It's castle. Capture. Push. Let's push this in front. Let's bring this in. Let's push this up. So let's capture if we can. Let's move the king forward and bring the rook here. If something threatens it, then we'll move the. Let's move this forward. Let's bring this here. We're attacking the rook. And we can attack the queen. Let's bring this here. And let's take it. Probably not the best move, but you know. Let's bring this here. There's not much protection. Stay as well. And yeah. And now then we'll just bring it forward. Say so I can capture this and then we can capture the rook. And S. Say if I bring the knight here. I bring it here, I'll force it where I'll just give it a check. Oh yeah. Okay, prevent it from going places. Capture. Okay. over here. Let's take this, let's just clean the board. Hmm. Then this here. Then I can go here. Capture. Get back. If he goes back, then it's back up. Oh my gosh, this takes so long to update. I thought it'd be quick. Yeah, there were quite a big blunders. But yeah, yeah, about this one will be a challenge. Now let's play some multi-tap. From hand where mates to stand. Your begin for when time. School ready. Set through again. State need. However, well tell such where and you all many deal them a line state should for thing or line thing new yet get my own can of word how much call like around new high around follow. Yes, 60. Consistency. And it dip less 50. Okay. Oh wait. The affair shows much lower values. Was my boss. What is the gray like? Off. Hmm. Disclosures. Can we like watch it and go through it? But then we will just be watching it twice. Essentially. Let's play another game. Let's keep it simple. Hmm. Feel like this is some trap or whatever, but let's play it. What should I capture to this? Let's capture to, and I can go back. Right. Let's capture this. Hmm. Let's go. Let's go back here. And this out. Capture that. Let's capture this in castle and bring things over. Go here. Hmm. It's castle. Um, can probably go here. And I'll kick this bishop out. And I'll push it out. Yeah, yeah, very good. I'll losing the calculation. No, and so 2 pieces ahead. And let's push this. Let's control this. Of this here. Uh, let's go over here. Check. Let's capture. Let me just double check. If I capture, he captures, I capture. That will be checkmate, right? Oh, it's pinned. Gosh. Yeah, that was my mistake. Let's leave this for now. Any move I make will be bad. So off. Yeah, that's all. All we can hope for is they'll make some mistake. Yeah. That was a big blunder. Let's try that. Yeah. Once you build the center, we'll pass hook to inside. Messed up. Was still updating, but I really locked myself in here to bring this out. Hmm. See, another good location to lock this from. I'll just move the queen forward. Hmm. Yeah, I can still prevent. No, I cannot. Yeah, let's just bring the queen here. Hmm. Oh, should I just restart? and so on. Right. Let's bring the rooks over. Let's capture. Let's bring this. You know that can do kind of. Let's capture. We'll capture one of the rooks. Oh, it's checkmate. Oh, don't even notice. This is like if I don't make any really bad mistakes, I think I can win. But yeah, let's just
Well,
watch
make sure to
this.
update all occurrences of this mistake.
I'll take
Okay,
a while.
first things first. Since our window will now be able to change dimensions, remove the const keyword from before.
And this one has a lot more code. Hmm. Jordan also option free command buffer, dynamic viewport, and scissor. What is the scissor? Hmm.
For the width and height variables. Next, add a new member variable, bool frame buffer resized. This will be used as a flag to signal that the window size has changed. Add a public function, bool was window resized, and return frame buffer resized. Next, add a void function, reset window resized flag, which will set frame buffer resized to false. Finally, add a private static function called frame buffer.
I really find this whole header file situation quite annoying. On C++ without header files. Is there like a way to do that? Use LZZ, take single file and automatically creates a .h and .cpp for you with all the declaration definitions in place. What is this LZZ? Update. Newer C++ can only be used within LZZ function body. Lazy C++. Okay, I think LZZ is no longer a thing. Is this still a thing? C++20 introduced modules with import instead of hash include. But as far as I know, only one compiler has reasonable complete support. let's see. Yes, I'm always wishing more language give me such an easy way to separate declarations from definitions. Can create an interface or just a parent class with unimplemented methods. Define if you really need that separation. Causes unnecessary runtime virtual. Let's see. Yes. Unless you're working, it's almost certainly not an issue. That being said, I agree it should be an option to not have to do. In C++, things are different. There are no modules, there are files, each of which can contain many different definitions. Done correctly, they are basically Cliff Notes version of the codes. As a website with cross-reference links to tags and functions. A good thing is that one just gets used to working with headers. But besides C++, I use a lot of Python as well. I can just import a module due to header files in C++ have to care about include guards. Mm, mm. That is it need to be split. When it comes to compiling multiple parts of a logic program, only defining headers. As long as your header has include guards, you should never see a problem. Headers are not going to go away for the next few years. Yes. What are these modules? C++ modules. And let's see. Oh, most C++ projects use multiple translation units, and so they need to share declarations and definitions across the units. Usage of headers is prominent. Yes, this is exactly what I was looking for. Hello world, export word hello. Importing modules and the units. global module fragment, private module fragment. Standard library module. Including headers. Modern implementation. Compilers. C++ compiler with module support. An interesting rabbit hole to have to go down to. That was back in 2021. C++ compiler support. And ranges and more. Okay, was being worked on then. Controller of module. Right, partial modules. Yeah. C++ 26. 23 features. There's no way to like sort it. Let's search. Partial are not done at all. Which compilers are here? GCC, Clang, MSCC, Apple Clang, Intel, NVIDIA NCC, Cray. Sucks that it isn't supported yet. It's still updating. Okay, no longer need this. CMake and C test. Wonder if all of this will work in Visual Studio.
Hi everyone, welcome back to our series on C++ extensions, new walkthrough, highlight forms comes in and link your code. That is the chance of making errors. So examples of build systems include Make, Ninja, MS-Build, CMake, which is a meta build system that actually lets you create any of these other build systems from the same file. And CMake is a really popular choice in the C++ community and has first-class support in VS Code. It's managed by Kitware, and it offers a lot of powerful features for managing large projects, handling dependencies, and supporting cross-platform development. Let's take a closer look at CMake. You can start off by installing CMake using the link in Kitware's documentation. In my case, I'm on a Mac, so I'm going to choose the most recent stable release for a Mac. If you're on a different operating system, you just choose the right release candidate for you. Then you just install the CMake tools extension. code, which just printed out a basic string. And in this case, we're going to update the string so it's more relevant in our case since we're building C++ code using CMake. And we're going to save that. So now it's going to print out debugging. Interfacing with the build process, code, which just printed out this CMake, and we need to tell CMake about a project and how it's set up so that it knows how to build a configuration file and then name it CMake list.txt. It's very important. However, each line depends on what you want the CMake build for your project, which in this case is project, which is C, just what I do this project. To this file, we have a CMake list.txt. There are two different. So today we'll be using example presets can include your generator if you want an executable for a Mac machine developers and to add to a continuous integration system. Now, as you add more and more and more, CMake presets.json, so I can just paste this in. And
I wonder. Still updating. I really should not have done this during the stream.
And make sure that it saves. But let's walk through this line by line so you know what a normal presets file looks like. First, you need to define a default preset, which is what we're doing here. Then you will see a list of settings for that or another generator. You also need to specify the when you build based on their name because their standard name. Build executable file I can run and the CMake icon be available in the activity bar. Next, I'm going to select my build target. So I should now have the CMake command available to set my. So in my case, it's my CMake project, which is the name I chose in my CMake list.txt. Now, when I navigate over to my project status in the CMake set to my CMake project, you can use CMake to generate any of the generated build files in the build folder of your project. Now you can use those files to actually build using the Build All Projects button in the side panel. This will create the final executable you need to run your code. You can also use the project outline to select a specific target to build for, but this is optional. Once everything has been built to your specifications, you can just run your code using the play button in the status bar. There we see the output that we expected our program to produce. So congratulations, you just successfully used CMake with the CMake Tools extension.
I have to check that out. Yes, cool. Let's see. Did I just remove it? Let's see, shadow. C++. Let's see. CMake results here. Oh, some of GitHub Copilot stuff. Which I don't want. Agent, HQ background agent, delegate. Editor experience. More easily identify open projects. So I have to navigate, choose into hello, code editing. Rename suggestions for TypeScript. Source control. Languages TypeScript 7. Wasn't TypeScript the one that switched the whole backend to Go, I think? No, was that another language? Say remote deployment, enterprise, contribution to extensions, build rollouts, improve website search functionality. Okay, is this still installing? Okay, the C line update is almost done. Yes, Let's back. Oh no, that was Visual Studio that opened up. Oh,
resized
it's
callback.
much a bit.
That takes a GLFW window pointer and an int width and int height. Now copy the callback function signature and open your window implementation file. Paste the function signature in and add your class name scope. Then, within the function, create a local variable.
Okay. The updating screen disappeared. We're going to load it.
Auto LVE window equal to reinterpret cast LVE window point.
And we have to open it manually. Let's see. Civilian. I think it's still doing stuff in the background.
GLFW get window user pointer. With the window pointer as the argument. Next, set LVE window arrow frame buffer window equal to reinterpret cast LVE window pointer GLFW get window user pointer. With the window pointer as the argument. Next, set LVE window arrow frame buffer resized to true. LVE window arrow width equal to width, and LVE window arrow height equal to height. And don't forget to remove the static keyword. Okay.
Yeah. It's still not loaded. Okay. The UI thing, the loading screen has shown up. Not much else.
Okay, now previously we've set the GLFW window hint resizable to false. Change this to GLFW underscore true. And then after we create the window called GLFW underscore
Okay.
with function
It's opening.
code as well. So make sure to update all occurrences of this mistake.
Okay. It's finally back. Okay, it's too much time in this update. Let's see.
First, since our
Window HPP. Let's close everything else. Okay, it's doing some scanning. We collect no data from users. Yeah, whatever. Let's wait. Yeah, shift and right click just closes it. Nice. Window CPP. First, we set to get rid of this const.
Change dimensions, remove the const keyword from before the width and height variables. Next, add a new member variable, bool frame buffer resized. This will be used
bool buffer resized fonts.
to signal that the window size has changed. Add a public function, bool was window resized.
Alternative bool was window resized. It's still starting the resharp engine.
Sized.
On frame buffer resized. Let's finish starting the engine auto. Loading the project. Let's get it all loaded before we continue. Let's go to the next steps.
Void function reset window resized flag, which will set
Already set it to false. Okay. Everything is loaded now at last.
Finally, add a private static function called frame buffer resized callback that takes a GLF
Static void frame buffer resized callback GLF window W window start
int width and int height.
window and width and height. Saved.
Signature and open your window implementation file. Paste the function
Let's copy this.
in and add your class name scope. Then, within the function, create a local variable auto LVE window equal to reinterpret cast LVE window pointer glfw get window user pointer, with the window pointer as
Let's see. Auto LV window equal to Get cast LV window start. Then package LFW get window user pointer window.
Next, set LVE window arrow frame buffer resized
LV window frame buffer resize equals to client ID is auto and now let's keep it.
LVE window arrow width equal to width and LVE window arrow height
Okay. LV window width equals width, height equals height. So save.
equal to height. And don't forget to remove the static keyword. Okay, now previously we've set the GLFW window hint resizable to false. Change this to
LFW true.
and then after we create the window called GLFW set window user pointer with arguments
GLFW set window pointer window this.
then call GLFW set frame buffer size callback with arguments window and frame buffer resize callback. Essentially, the GLFW library allows us to register a callback function that whenever the window is resized, the function will be called with the arguments being the window pointer and the window's new width and height. Additionally, the GLFW set window user pointer function allows us to pair a GLFW window object with an arbitrary pointer value, which in this case, we set to be the parent LVE window object. Now in your first app header file, add two new private functions, void recreate swap chain, and void record command buffer with a function parameter int image index.
Alright, then our first app HTTP. Yeah, we made all minor changes and all of that.
Function parameter
Void recreate, void offline, void recreate. So chain void record. Command buffer and index. Void command buffers.
file, add two new private function command buffer with a function parameter int image swap chain to be
and image index. Image index.
Swap chain to be a unique pointer and remove the initialization arguments. By using
std any pointer let's see.
rather than a stack allocated variable, we create a new swap chain with an updated width and height simply by constructing a new object. However, using small performance cost. Now, because LVE swap chain is a pointer, we need to use the arrow operator rather than the dot operator. So in your app implementation file, update each occurrence of this. Next, update the create command buffers function to only be responsible for command buffer allocation. So within this for loop, copy and delete this chunk of code where we record to the command buffers and remove the for loop.
What I had like
Where we record swap chain is a pointer, we need to use the arrow operator rather than the dot operator.
startups be default configuration. Pipeline layout.
So in your app implementation file, update each occurrence of this. Next, update the create command buffers function. Small performance cost. Now, because LVE swap chain is a pointer, we need to use the arrow operator rather than the dot operator. So in your app implementation file, update each occurrence of this.
Looking at this makes you want
Next,
to like
update the create
go to
command.
sleep. Replace. Yeah, nice.
Only be responsible for command buffer allocation. So within this for loop, copy and delete this chunk of code where we record to the command buffers and remove the for loop. Record command buffer with parameter int image index, and paste the chunk of code to record to the command buffer inside the function body. Then find it, remove the for loop.
What did they do?
Record to the command buffers and remove the for loop. Chunk of code where we record
Okay,
to the command buffers
yeah,
and
gets
remove
this
the for
idea.
loop. Then add a new function, void first app record command buffer with parameters.
A new function void first recreates option record buffers.
To record to the command buffer inside the function body. Then find and replace every occurrence of index I within the record command buffer function to use the image index value instead.
Match.
Int image index.
Like,
and paste the
okay, record command buffer.
chunk of code to record to the command buffer inside the function body. Then find and replace every
Okay, I'll just put in this section now. Control merge. Control C. Okay, let's do replace, replace. Yes.
command buffer function to use the image index value instead. Next, we need to implement the recreate swap chain.
Net frame buffer. Next. Oh, stuff. Listening to this Slack makes you want to go to sleep.
So right here after the create pipeline, I'll add a new function void first app recreate swap chain.
Okay, first app CPP, create command buffer. Void first app recreates option.
Add a new local variable auto extent equal to lve window.get extent. So
See, auto extend and for lv window get extent. While it's interrupt